The first substantial computer was the giant ENIAC machine by John W. Mauchly and J. Presper Eckert at the University of Pennsylvania. ENIAC, Electrical Numerical Integrator and Calculator, used a word of 10 decimal digits instead of binary ones like previous automated calculators/computers. ENIAC was also the first machine to use more than 2,000 vacuum tubes, using nearly 18,000 vacuum tubes. Storage of all those vacuum tubes and the machinery required to keep the cool took up over 167 square meters, 1,800 square feet, of floor space. Nonetheless, it had punched card input and output and arithmetically had one multiplier, one divider square rooter, and 20 adders employing decimal ring counters, which served as adders and also as quick access, 0.0002 seconds, read-write register storage. The executable instructions composing a program were embodied in the separate units of ENIAC, which were plugged together to form a route through the machine for the flow of computations. These connections had to be redone for each different problem, together with presetting function tables and switches. This wire-your-own-instruction technique was inconvenient, and only with some license could ENIAC be considered programmable. It was, however, efficient in handling the particular programs for which it had been designed. ENIAC is generally acknowledged to be the first successful high-speed electronic digital computer, EDC, and was productively used from 1946 to 1955. A controversy developed in 1971, however, over the patentability of ENIAC's basic digital concepts, the claim being made that another U.S. physicist, John V. Atanasoff, had already used the same ideas in a simpler vacuum tube device he built in the 1930s while at Iowa State College. In 1973, the court found in favor of the company using Atanasoff's claim, and Atanasoff received the acclaim he rightly deserved. In the 1950s, two devices would be invented that would improve the computer field and set in motion the beginning of the computer revolution. The first of these two devices was the transistor. Invented in 1947 by William Shockley, John Bardeen, and Walter Brattain of Bell Labs, the transistor was fated to oust the days of vacuum tubes in computers, radios, and other electronics. The vacuum tube, used up to this time in almost all the computers and calculating machines, had been invented by American physicist Lee De Forest in 1906. The vacuum tube, which is about the size of a human thumb, worked by using large amounts of electricity to heat a filament inside the tube until it was cherry red. One result of heating this filament up was the release of electrons into the tube, which could be controlled by other elements within the tube. De Forest's original device was a triode, which could control the flow of electrons to a positively charged plate inside the tube. A zero could then be represented by the absence of an electron current to the plate. The presence of a small, but detectable current to the plate represented a 1. Vacuum tubes were highly inefficient, required a great deal of space, and needed to be replaced often. Computers of the 1940s and 50s had 18,000 tubes in them, and housing all these tubes and cooling the rooms from the heat produced by 18,000 tubes was not cheap. The transistor promised to solve all of these problems, and it did so. Transistors, however, had their problems too. The main problem was that transistors, like other electronic components, needed to be soldered together. As a result, the more complex the circuits became, the more complicated and numerous the connections between the individual transistors, and the likelihood of faulty wiring increased. In 1958, this problem too was solved by Jack St. Clair Kilby of Texas Instruments. He manufactured the first integrated circuit or chip. A chip is really a collection of tiny transistors which are connected together when the transistor is manufactured. Thus, the need for soldering together large numbers of transistors was practically nullified. Now only connections were needed to other electronic components. In addition to saving space, the speed of the machine was now increased since there was a diminished distance that the electrons had to follow. The 1960s saw large mainframe computers become much more common in large industries and with the US military and space program. IBM became the unquestioned market leader in selling these large, expensive, error-prone, and very hard-to-use machines. A veritable explosion of personal computers occurred in the early 1970s. Starting with Steve Jobs and Steve Wozniak exhibiting the first Apple II at the first West Coast Computer Fair in San Francisco. The Apple II boasted built-in basic programming language, color graphics, and a 4,100-character memory for only $1,298. Programs and data could be stored on an everyday audio cassette recorder. Before the end of the fair, Wozniak and Jobs had secured 300 orders for the Apple II, and from there Apple just took off. Also introduced in 1977 was the TRS-80. This was a home computer manufactured by Tandy Radio Shack. In its second incarnation, the TRS-80 Model 2 came complete with a 64,000-character memory and a disk drive to store programs and data on. At this time, only Apple and TRS had machines with disk drives. With the introduction of the disk drive, personal computer applications took off as a floppy disk was a most convenient publishing medium for distribution of software. IBM, which up to this time had been producing mainframes and mini-computers for medium to large-sized businesses, decided that it had to get into the act and started working on the Acorn, which would later be called the IBM PC. The PC was the first computer designed for the home market, which would feature modular design so that pieces could easily be added to the architecture. Most of the components, surprisingly, came from outside of IBM, since building it with IBM parts would have cost too much for the home computer market. When it was introduced, the PC came with a 16,000-character memory, keyboard from an IBM electric typewriter, and a connection for tape cassette player for $1,265. By 1984, Apple and IBM had come out with new models. Apple released the first-generation Macintosh, which was the first computer to come with a graphical user interface, GUI, and a mouse. The GUI made the machine much more attractive to home computer users because it was easy to use. Sales of the Macintosh soared like nothing ever seen before. IBM was hot on Apple's tail and released the 286-AT, which with applications like Lotus 1-2-3, a spreadsheet, and Microsoft Word, quickly became the favorite of business concerns. That brings us up to about 10 years ago. Now people have their own personal graphics workstations and powerful home computers. The average computer a person might have in their home is more powerful by several orders of magnitude than a machine like ENIAC. The computer revolution has been the fastest growing technology in man's history.